Good morning, everyone. So this is for Tuesday's video, and well, it's the week of Thanksgiving. So happy Thanksgiving, everyone, in advance. If you are traveling about this weekend or this week, please be safe on the roads. If you're flying, please be safe that way. Appreciate the family members that are there. Remember those who are not, so on and so forth. With that out of the way. So the last couple of weeks, like I said, we've been really busy, but in the meantime, I've been looking into this whole artificial intelligence and artificial neural networks and how they work. And just in my idea, how are they going to transform into the future and how they will impact us. And of course, I understand it. At least on the simplest levels. Now, some of the artificial intelligence that are out there right now are very, very complex. For the like the AI that works for Google or Facebook or any of the large tech companies, they all have AI, or they probably have multiple AIs that do certain things. For example, if you are typing an email in Gmail and it gives you the word in advance of what it thinks you're going to type, that's artificial intelligence. Speech recognition in your phone is artificial intelligence. Some of the translation sites. So I saw an example when doing research on this that this couple was visiting Russia, but they didn't know any Russian at all. So they would take their phone out, take a picture of the sign, and translate it, and it would translate it to English for them. Those are all examples of artificial intelligence. And usually artificial intelligence does one thing very well, whether it understands images, whether it understands facial recognition, voice recognition, and some of them can be even programmed for stock markets and cryptocurrency exchange. Yep. But they're purpose-driven. They're specialized artificial intelligence. And the ones in the medical field right now are very advanced for what they do. If you've ever had robotic surgery, there is an artificial intelligence behind it. It still requires a surgeon to be present to override, just in case, because no artificial intelligence is 100% accurate. And that comes as a surprise to me, but then when you learn why, it makes sense. Now, again, these are artificial intelligence and artificial neural networks that make these decisions, and you're like thinking, well, that's a whole lot of code. And from what I have understand and looked at so far, and there are whole courses on YouTube that you could look at to understand it even more if you wish to dive into it. But I'm going to open up one of these images to explain how this kind of works. This is an example of an artificial neural network. So you have your input image here. This is the processing. This is the actual neuron, and it gives you the output. This is the thinking part, and this is emulated off of what the human neuron looks like in the brain. It receives a stimuli, it processes the information, it triggers a certain response or an activation, and then the output is then sent on either to your consciousness or to your voice or however. But this is a really simple example of a neural network, and this type of neural network is good for identifying photos. So, and you can teach it this way too, and this is what's got computer scientists kind of like baffled. It works mathematically, they understand how it works, but when you look at the detailed thought process, they are completely confused. That makes no sense to them. So, for example, let's say we were putting an image in here. And the one video I watched, they were distinguishing, had the artificial intelligence, and it was really almost this simple, although there was a lot more inputs. It was really this simple. The question is this image a cat or a dog? And so the image gets broken up. Some pre-processing takes place here. Some more processing takes place here. more processing here. The artificial intelligence then starts making a determination at this point, and then its best guess goes here. Now, in the beginning, when you're first using artificial intelligence, it is often wrong. That's why you have to train it, which it is how we teach kids, little kids, like infants and toddlers. We have to teach them right and wrong. Well, same thing here. So let's say we threw the images of a dog, it goes through the process, but the computer thinks it's a cat. You basically say no. And then with that, you backfeed it the information. So no, this is actually a dog, not a cat. And so it goes through and it makes corrections to itself all the way back to here. Not to the input layer, but up to here. The next picture you look at it, it'll make a determination. If it's wrong, it makes the self-correction. If it's right, it leaves it alone. This process, this one video I watched, it was just to determine if a picture was a cat or a dog. Took 8,000 images to train this little artificial network here. 8,000 images to train this to get a 98.76% accuracy rating. And it could look at that point, it could look at any image that you supplied it, provided it was just a single purpose image. So it was either a picture of cat or a picture of dog. There was nothing else in the image. I mean, you can have background stuff and stuff like that, but and it could be a side view, front view, top view, down view, it didn't matter. But with a 99% accuracy rating, it could tell you in that photo, from just going through the examples and teaching itself, is it a cat or a dog? And after about 8,000 photos that went through it, which depends upon your computer, anyone can have an artificial intelligence, at least of this scale. So it took probably 4 hours to have the computer teach itself the difference between a cat and a dog in a photo. And then after that, when they ran test samples, 99% accuracy or better. And I thought, okay, so this particular creator went into the details of the math behind it, and the math is not, it is complex, it requires some algebra, but if you understand the math, it makes sense. They talk about, you have to assign random weights here, some biases here, and then the computer, like I said, when it gets to this last point, makes an actual decision, is it a cat or a dog? And once you've trained it and taught it, it will know the difference between a cat and a dog. And it's absolutely amazing. I just, it takes a while. This is stuff that you take a toddler and an infant, and it might take you a year or 2 or 3 for the toddler to start understanding the difference between a cat and dog. Of course, they really don't care because their mind's not processing it that way. They just see, ooh, something fuzzy, it feels soft, it lets me pet it. But for a computer, so it took about, like I said, I think it was 4 or 5 hours for it to go through the 8,000 images. And then when they started doing actual tests on live data, with 99% accuracy, it was right. And every time it was wrong, it was confirmed wrong, it would go back through and readjust, this information, and this information to make sure it's more accurate in the future. This is really interesting. And this comes down, the other video I watched on this was detecting fake currency. And I saw this and I'm like, why don't every business have this? We kind of do to an extent. So with the, like Walmart, when you go to the self-checkout and you slide your money in the machine, it actually scans the images and detects if it is a legitimate bill or a fake bill. And so that's built into that process. And it really, after you train the computer to look for it, it takes no time at all for it to go through it. That whole process, give it an image, it looks at it, makes the determination real or fake. If it's real, it accepts it. If it's fake, it kicks it out and throws the light. But that process takes split moment. which is how we pretty much do it now, except for, we're a little bit slower in processing real or fake. But yeah, I'm sitting here going, but that's just whoever came up with that for Walmart or other companies like that. That's just brilliant. And I'm sitting here going, every retail business probably needs something like that, especially this time of the year. This is when the most cases of counterfeit happen, is the Christmas season. So, but anyways, back to this. This is interesting. It does one thing very well. Like I said, it determines cat or dog. It can detect counterfeit money if you train it, so on and so forth. The limitation to this is it can only do one thing. Now, there are other types of neural networks. They get very complex. So yeah, look at this. Just so you're aware, some of these, this is probably facial recognition here, traffic pattern adjustments here. These are just, and the amount of programming that goes into this is ironically very minimal. I was absolutely surprised that this example here, when I watched the video, took all of 20 lines of code. I was just befuddled. I couldn't imagine that. They loaded up 8,000 images, taught the artificial network to determine cat or dog, and it was done. Here's the interesting thing, and this is what I alluded to earlier, is when the scientists and the computer engineers and go back and they're looking at these images that is in the artificial network or the brain. It's not what you think. You would think that the computer, kind of like how people are, we recognize patterns. And so we can recognize, a handwritten A or a stop sign. Especially, if you're driving, most of us could spot a stop sign half a mile away because we recognize the color and the shape. And then when we get a little bit closer, we can, even if it's fuzzy and we can't see it, we can see the word stop. And so we recognize it by patterns. When they look at the details in here as to what the images look like inside the brain, they were completely unrecognizable. It was completely foreign. And you would think that, the computer would start learning patterns, and it wasn't learning patterns, and that was the odd thing. It learned something that's completely foreign. For example, the one other artificial network I was looking at was recognizing handwritten letters. And like I said, so you have, 35 outputs and 764 inputs. That's because each dot in the picture has to be translated. It goes through a double one like this. It takes about 8 hours to train the artificial network to recognize handwritten numbers, whether it be an 8 or a 9 and so on and so forth. Now, again, as we learn this stuff as children, we learn it by patterns. We just don't consciously think about it, but we learn it by patterns. So if I went 1, we knew that was a 1. And if I went this way, we know that was a 7 because of the patterns. 8, 9. We know these by patterns. The artificial intelligence that's doing this sorting doesn't see patterns. They recompiled the images at each step of this to see what the computer was seeing. It just made no sense. And I suppose in some way that's kind of analogous to human beings and their thought processes. Sometimes you're like, that makes no sense. It's the right answer, but it makes no sense. June is a perfect example of this. When she was in high school, of course, was taking algebra or geometry. I can't think of what it was. And she dropped out after 6 weeks of geometry and went to accounting because she could get the right answer, but she had no idea how she was getting the right answer. The math was beyond her, but she would get the right answer. And so this is the point that scientists and engineers and computer programmers are at, and this is why there's kind of been a slowdown on the AI process at the moment, because this part here, which is the brains of the artificial network, mathematically they understand how it works. But when they're looking at the images, so like I say, you put the 9 in there, a handwritten 9, and the computer tells you it's a 9. When they look at these images that are stored in these axions, or, neurons, whatever you want to call them, when they put them back together so they can see what the computer is seeing, it's garbage. It's junk. I mean, the one guy pulled out and he goes, "You would never know this was a 9. But somehow this works." And it's amazing that it works. And like I said, once you train your artificial neural network to do this, it is almost right 99% of the time. Now, training on some of these more complex networks, when you get into these things and facial recognition and so on and so forth, they can take months to train because they have to run through and reprogram themselves and run through it and reprogram. It takes months. I'm sure, kind of like the banknote ones, or big data, as they refer to in science or financials or whatever. That just takes, days, weeks, and months to train an artificial network to give you the right answer. But, along the way, along the way, they have no clue. They know it works. I put gas in my car and I step on the gas pedal, it goes. I understand how it works because I was taught that in school and through my own, through the years, taking care of my own car before I hired professionals to do it. I understand it. Scientists are now looking at this and like, it works. They understand the math, have no idea why it works. Isn't that a little scary? So this is why, our specifically driven artificial intelligence is going to be around for a very long time. It's not going anywhere. General artificial intelligence, this is going to be your androids and robots in the future. Those are going to be many, many decades off, because there's just way too many inputs. There's no way you can make one. We don't have the computing power for it now. So when they go and look at physicists and scientists, astronomy people go and look at making models, and we've all seen models on TV or on YouTube or whatever, where they're like the collision between Andromeda and the Milky Way in about 2.5 million years, and it's a simulation. That's because an artificial intelligence did that, and again, they understand the math behind it. Couldn't tell you how it came up with it. It's just how it is. So yes, specialized artificial intelligence to do one thing or two things, that's going to be around for forever, because we've gotten that good at it, although sometimes we just don't understand. Generalized artificial intelligence? No. Right now, probably the most advanced robots we have on the world right now is the ones at Boston Dynamics, and you've probably seen the videos of them doing balance beams and flips and coordinating and dancing with each other. Or I know Boston Dynamics will take one out when they're running a military application and give the thing a gun, and it shoots the right targets and leaves the other targets alone because of the programming in it. But that is not only an artificial intelligence, but there's overriding programming to it to allow it to do that. It doesn't have general intelligence. And I don't know if we will ever get to the level of general intelligence. An overall, a robot or an android that knows everything or knows a little bit about everything. I don't think we'll ever get to that point. It's still a developing field, though. The first real artificial intelligence was theorized in the 40s or 50s. We didn't have the computing power until about the late 80s. I think I saw a video where it was saying that the first artificial network that came out was in 1988. And so they had vastly improved. Obviously, law enforcement, government agencies, big corporations have vast arrays of artificial intelligence to do very specific things. Either we're doing facial recognition, voice recognition, predictive text, stuff like that. But otherwise, as a generalized overall, hi, my name is Bill, I'm here to help you, that ain't going to happen anytime soon. because there's just way too many inputs and the processing power is not there yet. So, but yeah, I thought I would share this with you because I know everyone's concerned about, to some degree or another, thanks to movies, science fiction horrors like Skynet, Terminator, and Alice, if you was watching, oh, what was that show? Anyways, Alice was an example of it. Yeah, everyone's afraid of an artificial intelligence. Well, general AI we might have to be concerned about, but specialized AI, we still have way too much control over it. We can flip a switch and kill it, and it'll be perfectly fine. So, yeah, interesting stuff. If you want to learn more about this, oh my goodness, like I said, there are tons of videos on YouTube, and then of course there are college courses and classes, or I think even Brilliant's got some information on this stuff. And when you do the math, don't be surprised. Especially the more inputs and the more nodes. These are called nodes. The first one is called a node, and then this is called an activation, activation. The more you have into that, the more you have to program it. And it's not really complex. It's a lot of repetitive parts. But yeah, I mean, you could study this on your own. If you understand the math, or if someone explains it very well, it'll make perfect sense to you. If they don't, or you don't understand math, this is going to go right over your head. And you really don't need anything higher than, from what I could see, pre-algebra or algebra 1. And so there's nothing really complex in an artificial neural network on a simple level. I'm sure when you get into higher, more complex ones, there are. So, but yeah, I thought I would share this. I might tinker with this myself once we get some other projects out of the way, or it might go in tandem with a project. We got the new credit card machine on the vending machine for the ink. It just hasn't been activated yet. The whole process is slow. We got the new locks on lock boxes. Some of you have probably noticed that we put your computer, if it's waiting for pickup, we'll put it in a lockbox and actually lock it. So maybe I might use facial recognition in the future to allow you to drop off and pick up your computers through that. It'd be interesting to see how that works, especially running it on a network and also on a tablet or a small scale computer, to see how it works. I'd probably have to do it as a virtual machine to allow it to have the independent processing. But yeah, interesting, good stuff. Definitely, if you want to learn it and study it, by all means. If you have no idea, don't give a rat's butt about it. Don't. But it's always nice to know about the technology that's working around you today. So, certainly at the moment, this is beyond my pay scale, but eventually I will learn it because I will want to utilize it myself. So, anyways, you guys have a great Thanksgiving weekend. Enjoy it. Be safe. Appreciate the family and friends that are around you. Don't forget to take a moment to remember those who are no longer with us. And just, be safe out there. You guys have a great day.